Now, if knowing that distance, we can, let's say here, calculate average distance. And let's remove now all the points that are further away than from each other than that number. So basically, we'll create another, now we'll create a point wrangle called eliminate strays, which is kind of diabolical, but yeah. And we, for each point, we'll see if we have a neighbor within a certain value that's based on the average distance. And if we do have a neighbor within that value, then fine. But if we do not have a neighbor, if we can't find another point within that range, then we'll consider our point to be a stray point, and we'll just remove it. So again, we'll create a integer list of my neighbors, and it's going to give us the near points within 0 based on our current position. And we want to detect a maximum of 2 within the threshold distance. So let's define here a threshold distance. We'll use this as a variable, or yeah, let's use this as a variable. This is going to be a variable that we're yet to define. Thresh dist, and a maximum of 2. Now let's figure out what that thresh dist is. So we can access the average distance that we calculated. Let's bring it in. Average dist. It's going to be equal to detail. It's a detail attribute from our 0 input, and it's called average dist. Okay, so now we're bringing in that value that we calculated on the previous wrangle. And we'll establish kind of, let's say, float. Thresh dist is going to be equal to, we should have a good margin of error because some of these points might be very far apart. But let's say if the thresh distance is going to be 10 times the average dist. Any point that doesn't have a neighbor within 10 times the average distance, it's going to be considered a stray. It might not be enough. We do have a good coverage, overall coverage on this, but as you can see, some areas are kind of occluded, and these might kind of disappear a lot. Usually those stray points are really far away from each other, from the rest. Okay, as you can see here, much further away than 10 times. So we can actually increase this quite a lot. Let's start with 40. It's actually safer, I think. And we'll see how that works. This is something that we can also create a controller just for this. Let's go with that. Let's go create a controller, a float controller called dist molt, or let's call it thresh molt. And let's create it. Let's set it to 40. And that's basically it. Now, we'll create an if condition. If the length of our list of neighbors, my neighbors, is smaller than 2, meaning that we're always going to find ourselves, our point. So for each point, we're always going to find ourselves on this list. But if we can't find anything else, if our list just includes us, then in that case, we will remove ourselves from the equation. We can actually write this on the same line. Since it's just one line, we'll remove point from 0 ourselves. So add pt and let's say there's another item that you usually want to define or not. I usually set it to 1. It just means that if you had primitives, it will also include erasing or removing the primitives associated to this point. Now let's see how this looks. We have an error here, too much parentheses. It should be running over code, all those million points. Vex is beautiful because it's really, really fast. And if we go to our side view, we should see that we do no longer have a straight point. Okay. Go up here, we can see the straight point over there. And after running our two wrangles, we'll see that we no longer have that problem. So problem solved. We managed to create a simple algorithm that calculates the average distance, and based on that, it will eliminate any point that's not within a certain margin of error um, of that distance. Let's see how many points. What's the difference between point count? So here we have 19,295,484, and here we have 483. So it was basically just that single straight point that was the cause of all of this extra vex wonderfulness. And yeah, it's always interesting, and it's a good thing to solve these problems. You really learn quite a bit and learn how to feel comfortable with dealing with this type of situations and figuring out a quick way of solving them. Okay, so having done that, we'll move on to the next lesson to finalize this part of the process.